I did drink 1.5 beers on stage at YOW, but that was because just before going on stage, I had been in the middle of an incident call. So I feel like that is related to my material today. So there we go. Yes. Anyway, this is a talk about continuous verification. Yay. Yes. Yeah. And I'm Kat, and people are always like, oh, how are the things that you work on related in your head? And they're related like this. The things that I'm interested in either shouldn't exist anymore, okay, or they shouldn't exist yet. And that's kind of where I'm at. So that's what I kind of like to do. And then the other thing that I'm really interested in is that software changes faster than soft tissue in many cases. And I'm interested in how that affects society, the fact that our technology can change so much faster than our stupid brains can. Okay, so now let's talk about continuous verification. Woohoo! I said that we would go beyond chaos engineering to continuous verification. So that means that we have to actually know what chaos engineering is. So if you don't know, it came sort of from Netflix, this practice basically where you experiment on a system so that you can gain confidence about that system's capabilities and performance. And if you want to know more about that, there's principles of chaosengineering.org. Yes, .org. Yes, so that's basically what it is. What are you doing? You are perturbing the system in some way and seeing if customers still have a good time. That's essentially it. It's essentially chaos engineering. And I did mention customers there, so it is typically something that happens in a production setting, although not always. Yes, so basically how did folks arrive at the practice of chaos engineering? By asking this question, right? Instead of trying to avoid failure, what if we just treated failure as inevitable, right? So we're not trying to engineer systems where we avoid failure. We're just admitting to ourselves and whatever deity that we understand failure will happen. Do our systems have the ability to recover from that failure? Will our customers have a good time, or will they be significantly impacted by that failure? So that's kind of it. Like, why are outages and kind of these unicorn companies really notable and newsworthy? Well, because mostly those systems are able to kind of absorb those failures and make it so that you and I, customers, don't have a terrible time. So that's kind of the mindset of chaos engineering. We're going to treat failure as just an inevitable thing that happens in these complex systems. So that's chaos engineering. Now, what is continuous verification? So I think that chaos engineering takes something, we perturb the system in some way, we, do something, and we ask, is this safe? So we define what this is, and we try that, and we say, is this safe? And continuous verification asks, what is safe? Right? So we're going to perturb the system, and we're going to try to creep up to the safety margin. And then when we reach that, we're going to back off. So we are not really trying to introduce failure here. We're trying to reach out and kind of feel the edge of the safety margin. That's what continuous verification is. So in chaos engineering, we're trying to build that trust and confidence. We talked about in the first slide, and the kind of definition of chaos engineering. And with continuous verification, we are trying to build awareness. So where is that safety margin? And is it shifting? What is it doing over time, right? Because it's not a static thing like, oh, once we found it, it just stays there. It moves as our systems evolve and change and as the market evolves and changes. So we're trying to build some awareness of that boundary and then ask ourselves, okay, where is that boundary headed? What should we do about any changes, if we should do anything at all? So that's kind of what I think the big distinctions are between chaos engineering and continuous verification. So that means you could have a chaos engineering practice within your organization. You could also have a continuous verification practice within your organization. And I think they could be two separate things. So you could have chaos engineering tooling, and you could also have continuous verification tooling because they have slightly different aims there. Okay, so I mentioned, drinking beer on stage after being in an incident call. And I have been on many more incident calls than I would care to admit at this point in my relatively young life. So how do we arrive at those? We have all of these things. We have this root cause analysis, and we have all of these interesting things that we do to try to find the source of the issue and remediate that. And in chaos engineering and with continuous verification, we don't believe that there is a root cause or that there's some, just distinct event that by itself pushes us over the safety margin, into that bad area or even across the safety boundary, that performance boundary that we have where our customers are now not having a good time, right? So in complex systems, there's this whole body of research around safety and resilience. And what those fine folks have found is that you don't actually just tip over with some big event into chaos, right? It is a drift into chaos. And there's some great examples in this book by Sidney Decker, Drift into Failure, and I highly recommend you read it. Probably the most notable example that I bet many of you have heard of before is a plane crash in the United States where there was a part that was supposed to be maintenanced at some short interval. They were maintaining it. It never needed to be replaced at that interval. So then they lengthen the interval. They change it from flight hours to miles or something and back again, all of these different things, right? They're just kind of tinkering with this safety margin, it looks like it doesn't need to be replaced at any of these checkpoints. We're going to put it into this other maintenance schedule. We're going to do these things, and eventually a part that has been really reliable is no longer reliable, right? But it had to go through all of this drift in order to reach that point. So that same part is functioning perfectly, getting people where they need to go extremely safely, and then until it's not, because there's this drift. So that is also what we see in our socio-technical systems, where there is this drift into failure rather than some distinct event that causes the failure. What we typically see is that it is drifting. And we see our systems drift to the very edge of failure, kind of right before you tip over into chaos, because that's where we're getting max efficiency and all of these things, right? So you may have seen this triangle before, Rasmussen triangle of sadness, or whatever you might want to call it. But basically, what we're seeing is that we push towards that safety boundary for the performance of our systems. So I'll show you what this is in case you haven't seen it, but I know many people have, so I'll try to be speedy, quick. I'm wearing these green glasses because I have a headache and it's supposed to make it better, but also the green line on the screen, like doesn't look good with the, so anyway, you don't need to know that, but I'm just letting you know what's going on in my life. Anyway, so there's one boundary for our business, which is an economic boundary. And if we cross that boundary, we go out of business, which most people collecting a paycheck agree is bad. So there's that boundary. And that kind of defines one edge of the space that we're going to play in. The next boundary would be the workload boundary. So this is where there's just too much work to do. Our people can't do it. Again, going back to some of my favorite incident calls of all time, I've had people fall asleep on incident calls, right? I've had people just straight up pass out, right? All of these things. So there's a workload boundary within our system, and also like our brains are wired where we're just trying to find a way to not expend effort because that is bad for our survival. So like I said before, our brains are changing more slowly than our systems. So we're still wired to be like, oh, conserve energy, so that's kind of a thing that we do. So that's two edges of the space in which we're going to play. And then the third one is the performance boundary for our system. So when we cross this boundary is when we have an outage or something like that. The system is no longer performing in the way that we need it to. But the interesting thing about the performance boundary is that we kind of have this little buffer space that we like to creep really close to. So we know, okay, here at this point, it's broken. Can I kind of get closer and closer to that, right? So just like the parts for the airplane, like how close can I get to that boundary before everything tips over? Yes. So there are all these pressures, and we already know about the pressure of like, make it cheap, right? Or adhere to whatever accounting practices or whatever the case may be. Like, I'm sure many of us have had these great conversations about like, where do servers belong on a balance sheet or something like that, right? So there's this economic pressure towards cheap. There's the workload pressure towards easy, right? We're trying to find where we don't have to expend that energy. And then those things push really hard and they push us over the safety boundary. And then we have an incident, and then that causes pressure that pushes back and says like, hey, you have to do this in a safe way. So it's kind of a pressure away from incidents. So what I think is interesting here is that we kind of have like an idea of the economic boundary where we're kind of measuring that at some sort of cadence, right? And we kind of have somewhat of an idea about the workload boundary, right? Like, are we operating within the capacity of the team or whatever? But this performance boundary, we're really only sensitized to when we cross it. So we have some tools that have become more widely adopted, like SLOs and SLAs and those kinds of things, where we try to keep things inside of that safety margin. But there is like a lot of pressure to kind of experience that event of the incident and then just pull back from there. So like I said, there's the economic forces and there's the workload forces, and they're pushing our systems to the edge of chaos because that's where they're operating in a way that is cheap and easy, right? So yes, those things are maximized. And now we have this interesting drift of the safety margin where it's getting closer and closer to the actual performance boundary. And we kind of develop just these habits around that, right? Where like if you've ever worked on an ops team, and there are things that happen in production and you just automatically react to them, right? And you don't like open a ticket or send that information back to the dev team. You just kind of do those things. And that's a good indication that that safety margin is drifting closer and closer, because there are things that you've now like developed this muscle memory to just react to them. So yes, I'll share some horrible stories with you, which will be nice. So what that is, that's the normalization of deviance, right? So the first time it happens, you're like, what the heck happened here? Like, this shouldn't be happening. But then you find this little remediation that you do, and it's like, not a big deal. And then the next time it happens, you're like, oh, don't worry about it, Susie, just come over here and I'll show you what to do when that happens, right? And then it just becomes like more and more accepted. And now suddenly there's a wiki page like, oh, when you see this weird thing happen, you just do this and it goes away. Well, there we've just normalized the deviance. Really? You know, we should be saying like, hey, if that shouldn't happen and it is happening, that probably means that the safety margin is creeping. What do we do about that, right? And that causes us to ignore and become desensitized to all of these weak signals that our system is sending us. So then the safety margin and the safety boundary just keep getting closer and closer together, and we're kind of just doing the things that we need to do to keep us barely on the other side of an incident until you just can't do that anymore. There's one small additional change just makes it so that your little wiki page, whatever, doesn't work anymore. And unfortunately, I've been there many times. Yes. So now I'll tell you, it's story time with Kat. This is a true thing that happened to me. And, you know, I've made my peace with it. So there we go. This was a real thing. It was really documented in a wiki on a team that I worked. So we knew and communicated that at a certain point, we knew that this code that we had put into production would break. And we did not know the point. Said, well, it could be 3 months from now, or it could be 2 years from now, or, you know, just not really sure when that's going to happen. But for sure, it will break at some point, right? And we had this whole, you know, different solution that was supposed to follow very quickly. And it was already in the works, being developed, all good to go. And you know how life is. Once we got the kind of stopgap thing out there, people were like, oh, it seems like it works fine. And we said, well, sure, it will work fine until it just completely blows up. And they said, well, let's just cross that bridge when we get to it. And we got to the bridge. And the only way that we could fix our teeny tiny little problem was to delete some production data. Yes. And so we did that, you know, because that's the thing that you do in the world. Is fine. Don't worry about it. And I mean, it got to the point where we were like, well, just make sure that that data is always deletable, basically. Yeah, it was terrible. But you can see how this had happened, right? Because we had leadership. They're like, well, it's probably going to be expensive to replace that. Do we really need to do that? We're going to have to like probably put in time with other teams so that they can consume this new capability. It sounds like just a big expenditure of effort and dollars. And so because the event, you know, they hadn't experienced that incident, right? They were just like, let's roll with it. And then we experienced it. Not very fun, but now we have our wiki page that says just delete a small amount of production data every time. It's cool. And so the next time it happens and we delete data as you do, this is the feedback that we got. Well, it's not an incident because as soon as it happened, you fixed it. Like, no, just to be clear, I did not fix it. I deleted data in production. Most people frown upon that, but it seemed cool with everyone, right? Like as soon as you do that, transactions pick back up. Everyone can do whatever they need to do in their cart. So that's not an incident anymore. It's fine. There's wiki page. It's cool. I decided to invent a new thing, which I refer to as the 90-day incident, because that safety boundary, so originally it took months and months for us to approach it. However, the next time it took half as much time. And at that point, we had several of those weird behaviors all right back to back. And then it occurred again in half of that time. And then we had double as many failures clustered together, and it happened in half as much time. So that safety boundary was moving, basically closing in on us and suffocating us. So I decided, because the metric at the time was the mean time to resolution. So we want all incidents to be very short. So I said, well, truly, let us reflect. When does an incident begin? And when does an incident end? So I chose to use one cluster of these failures as the beginning, and then just let the clock keep going as long as the failures kept happening, right? Because they're happening closer and closer together and more of those failures. And that was the only way that we could draw attention, by leaving that timer going, to this issue, right? That the safety boundary was kind of closing in on us. So yes, that's my horrible story for all of you. And I hope you enjoyed it. Now you know, those kinds of things are in my life, and you can excuse me for drinking on stage. But this is the weird thing, right? We had a mature pipeline that ran, right? A great test suite on that. We weren't lacking a whole lot there. That code then had to be promoted through several different environments, right? Where other teams are interacting with that code. This thing never happened in any of those non-prod environments. It only happened in production. And after a lot of research, we were finally able to, simulate the same behavior in a non-production environment. But it was like a huge expenditure of effort for us to actually figure out how we could trigger it. And that's normal, right? Like, why do incidents happen? It's because there's something that we can't anticipate based on the information that we have from our test suite or the behavior in our non-production environments. It's just more and more difficult to actually create meaningful experiments in a local environment that can give us the information that we need, because there are so many things happening in production, like the rate of change, the maintenance of those systems, all of those things that we can't really model in a tiny way. The only way that we can find out what is going to happen in production is by being in production. That's why we've gotten really good at getting our code into production. What we haven't gotten as good at is kind of poking production and seeing what happens as a result of that perturbation. So what what we're doing in continuous verification is that we are in production trying to find the safety boundary of all of those products or systems interacting. So it's kind of what we're doing there. I hope that makes sense. So that's, I'll add a little bit to the distinction that I drew before. Chaos engineering is asking, is this safe? And continuous verification is asking and keeps asking, what is safe? And we're trying to find that in production because we know that the boundary will exist in a different place in production, in whatever staging or integration environment, whatever dev environment, the safety boundary will be in a different place because that safety boundary is a product of all the interactions of the people and systems in the ecosystem. So that's why it's really important to have these things in production because that's where we learn about the safety boundary. And even in my story before, like I painted as being this horrible thing, but we did actually get ended up getting some leading indicators. Like we know now we are approaching the safety boundary. We're about to see a cluster of those failures. Of course, we can do anything about it at that point besides be ready there with the delete key. But, you know, at least we knew it was coming. So then we could at least tell the other teams involved, like, hey, give me about 30 seconds, you know, like jump in here and delete this. Anyway, yes. So what we're doing, we are proactively looking for that safety boundary, making it conspicuous before an incident occurs. So we know that it's going to be conspicuous in an incident. We're trying to find the boundary, not do any kind of failure, and then back off once we found the boundary. That's what continuous verification is about. And yes, I'll call out a few words there. So tooling. People tend to get really upset when I say that continuous verification is tooling because I think people want everything to be like a mindset shift, right? Like if I change my mind about production systems, I will be able to identify the safety boundary. That's not actually a thing as much as I would like it to be, but I've done a lot of meditating and it hasn't worked. So for anything basically with continuous in the name, continuous integration, continuous deployment, whatever, you're going to need tooling because human beings are not like continuously engaging in socio-technical systems like that. So yes, it has continuous in the name, continuous verification. That means that it is tooling for identifying the safety margin over time. So you need tools to push something up to the safety boundary and then back it off. Also, like, would you not hate to be that human? That's like, I'm going to keep pushing this button until it gets right to the edge of the boundary and hope that I, as a human being, can perceive the edge of that and then back the thing off manually. That seems like a pretty inhumane thing to do to a human. I don't know. Yes, so continuous verification is tooling, not just a shift in your mindset. You can't go on a yoga retreat and become continuous verification, and it's over time. So we're not so much concerned with identifying the safety margin right now, today. What we're looking at is for what that safety margin is doing over time. So it's cool if we find it today. Yeah, right on, sweet. But the safety margin is always moving, right? All of those forces pushing in different directions, and then we're introducing changes. And so we want to see where the safety margin is headed over time, which is another great reason for it to be tooling. You know, I love Excel. just as much as the next gal, but you probably need something a little bit different to look at how that safety margin is trending over time, and then to make sure that you are always just approaching it and then backing off. Yes, because we have this normalization of deviance, so we as humans can't perceive it. We need tooling where we say like, hey, these are the things that we think go into defining the safety boundary, and then we'll have this tooling that doesn't make like normative judgments on things, and it won't care like how we feel about the safety margin. It will just approach that. Okay, so that's continuous verification, and it's kind of why it exists, but why now? Like right now in human history, why is this happening? So continuous verification, if it's this tooling to sensitize us to the boundary, it is boundaries, safety boundaries in complex systems. So now we have systems that are complex, right? We have a digital landscape where lots of products are interacting, and even the people in our ecosystem are being rapidly influenced and interacting with our products in really different ways. So what does complex mean? It means all of these things. I love word art. So when a complex system is one where if you decompose it into parts and you really get to know those parts, you won't necessarily get to know the system, because the essential properties, the defining characteristics of the system are a product of the interactions of the parts rather than the parts themselves. A complex system is also acting on itself all the time, which is cool because that means that it kind of like contains history, but also not cool because it makes it do weird stuff, right? We have all of these emergent behaviors. The other thing that I find extremely irritating about complex systems is that you can only kind of know what's going on in retrospect. And so a good way to tell that you're working in a complex system or a complex ecosystem is if you hear a lot of people, something happens, I had a feeling that would happen. Yep, I had a feeling. And you're kind of like, well, if you had a feeling, why are you only bringing it up now, right? So I will always remember that when I watched the movie The Sixth Sense, everyone afterwards, like, I knew. Remember that scene? I knew. Or like you watch Fight Club and remember that scene with the bus? I knew. You didn't know. I watched the movie with you. You didn't know. You only knew afterwards. And that's what complex systems are too, right? Like people will be like, I had a feeling that was going to happen. You didn't, or you would have done something about it instead of letting us crash and burn. So that cause and effect is only observable truly in retrospect. Which is also kind of cool, right? Because that means that if we create lots of opportunities for retrospect, then we can probably learn some cool things about our system, right? So usually we have an incident, and that's a great opportunity for us to reflect on how we got here, and then we can see cause and effect. It becomes more obvious. If we perturb the system ourselves, then we have an opportunity to, whatever, retrospective coherence, make sense of cause and effect. So continuous verification needs to happen right now because we have complex systems. We need to be perturbing them continuously so that we can learn about what the heck is going on there. And they just will not stop changing, probably because of this, right? Deliver working software frequently. I don't know if you've heard this. It's part of this document called the Dad Pants Manifesto. Very popular the world over. So they said this, that you should deliver working software frequently. I, as a millennial, do not know what that means. I understand what it is to like deliver working software at the time. I don't know what it means to keep that software working with every single new thing. You're continuously delivering working software. Like, that is a horrible nightmare. So I think that we probably need to separate those things and say that we deliver frequently and we keep it all working. So if we are continuously introducing change into a system that is already complex, then we need some tools to augment our ability to keep it all working, to kind of sense the boundaries of it working. So our brains have this idea of how the system works, and that idea manifests itself in our code. It manifests itself in our tests. Unfortunately, whatever model we have in our heads is already outdated. So there are a lot of times when we write code with the idea of production that we have in our heads, and then by the time it makes it to production, even if that's a very short amount of time, the model that it was based off of in our heads now is conflicting with reality in a bunch of really interesting ways. So in the book Chaos Engineering, Casey and Nora define that kind of thing this way: when a gap of expectation exists between two or more engineers separately writing code, then the interaction that code may produce unexpected and undesirable results. So we want to get to production frequently, basically, and we want to see what the heck is actually going on in production. I think that there's also an element that's not really captured in that. Not that I'm any smarter than them, but like I said, I've been on a lot of incident calls. I think we write code, each of us with our own models in our heads. And then when that code meets up, interesting things happen. So we got to get it out into production. But also the environment in which that code is operating, I mean, like the society in which it's operating is also always changing. And especially now with the way that information moves, is changing very quickly. And so we can have the difference between what is in our model in terms of the code itself, and then we can have the difference between what is in the outside environment and market and the model that's in our heads. And the only way that we can kind of figure out what's going on is if we make it into production, and then if we want to be able to use those muscles that are like the retrospective coherence muscles, we need to give ourselves, like, we need to perturb the system in production so that we can be like, hey, oh, I can see how that happened, or I can see why that safety margin is moving. So we're trying to give ourselves an opportunity to reflect on cause and effect in the system and understand how things are trending over time. So not where they are at this very second, which will immediately become outdated, but where things are moving as they're under pressure from all of those forces that I discussed earlier. So I think it basically boils down to this, right? We have this idea like, yeah, this is the place where our system exists. This is the thing that it does, but it is always different, right? So, oh yeah, here's the river, right? Oh, okay, cool. But it is always different. And we have to kind of continuously build our awareness of the way in which it is different. And I think that's what continuous verification does. So we move from asking, is this safe? Can I unplug the server and plug it back in? Is that safe? And now we want to move to asking, what is safe, right? So how much can I perturb the system in which ways before I begin to approach that safety margin? Yes. So I think that's it. Yeah. I referenced several books, but these are like the standout awesome ones, I suppose. So the chaos engineering book, obviously, and it does go into some detail on the difference between chaos engineering and continuous verification, and then Drift into Failure, which is an amazing book and will make you afraid of everything and simultaneously really excited to be alive. So yeah, I think that's it. Cool.
Thanks, Kat.
Thank you.
I have to say your description of that last book makes me think of just 2020. Right?
Yeah. Yeah.
I have lots of questions, but I wonder if anybody else has questions. Do friends on the call have anything you would like to ask Chaos Cat about continuous verification before I expose my ignorance and ask all the dumb questions?
Just a quick one. You mentioned tooling without plugging any particular vendors. Any types of tools that come in handy?
Boy, that's an interesting question. It depends, right? Like if you are looking for continuous verification, like at the application level or anything that has anything to do with like business logic, right? Then I am so happy for you that you're on that journey, but also you're probably going to have to write it yourself. But there are like tools that you can buy, and I did work at Verica, and so I can attest to the fact that that seems to be a thing that is imbued with my knowledge of being on way too many incident calls. But like depends on how context specific it is, right? If you're looking to find the safety margin as it relates to like your infrastructure or enterprise service kind of offerings, then yeah, you can probably get tooling. But if you're looking at some like nitty-gritty application level stuff, then you're on your own. Sorry, is that really dissatisfying?
No, it's par for the course for this sort of stuff until there's a sufficient mass of people demanding it or writing their own, and someone spins one off. You do have to roll your own or cobble together things like logging aggregators and observability tools, cobbling them together with various homegrown dashboards to help you see things, see the tsunami as it's coming.
I totally think that that's an option, like looking towards observability. However, you still have to perturb the system, right? And you have to kind of close all the feedback loops. So make the thing smart enough to like back off from the safety margin, which is not a huge amount of fun, but it's more fun than deleting production data.
That was actually going to be one of my questions. It sounded to me like observability plus poking things is kind of what this is. Yeah,
you need the poking thing in the closed feedback loop. Yes.
Which sounds easy-ish to describe, but
computers are terrible.
If I was going to do this, I'd just be like, where do I start?
Oh, yeah.
Even like I vaguely know about chaos engineering, unplug the thing, whatever, but how do you do it without crossing the line and manufacturing your own incident? Oops, I meant to perturb, and I'm sorry, I just destroyed the place.
Yeah, that's the thing though, because it's not, whatever you make for continuous verification tooling is never going to be like mission critical, right? So if there's something in the current circumstances where you think to yourself, gosh, I mean you, meaning the computer, thinking to itself like, gee whiz, seems like this one, there is some risk here, some additional risk where it might not be safe. You can afford to be really conservative there and be like, hey, I don't even think we should run this verification because there is something in the circumstance that causes us to believe that it might not be safe to run the verification, right? And that in and of itself is a data point. If you start seeing some trend in that, like, wow, verifications are always queued up to run at this time and never do because of whatever, that's a good bit of information about our systems and a good bit of information about the continuous verification tooling that's in place. How could it be safer, and how could we both be changing the tooling and the systems to move towards safety?
The other thing I kept thinking of, and I don't know if you've seen the videos of IKEA testing chairs, and they just have something that pounds on it like 10,000 times. Like,
yeah,
not quite production, but okay.
I like it. Yeah, but it doesn't have to be production, right? Because all we're trying to do is like mimic the perturbations that could be out there in production, right? But like, it doesn't have to be the actual thing, right? Like you could lose a data center or something like that, right? And like, are you really going to do that? Happen. You know, I would not recommend it, but you could have like some agent, right, that introduces enough latency where whatever is on the other side like freaks out and is like, oh my God, we lost the other data center or whatever, you know, so you don't actually have to lose the thing, you know.
Don't burn it to the ground. Not a test. Yeah.
I mean, it depends on which data center.
Who else has a question? I'm setting fire to things. Anyone?
I'm so good that no one has any questions, or they're just like traumatized by even thinking about some of these things. They're like, oh, no thanks.
Are a lot of places, I mean, I'm imagining, and I'm still laughing about the Dad Pants Manifesto. I imagine this is maybe like the sort of thing that people talk about doing a lot more than they do. Are there many companies out there that are kind of all in on this? I mean, obviously you mentioned Netflix, but is it pretty widespread now? Is this the next hotness?
I think chaos engineering is getting more and more widespread, but I think the trouble with continuous verification is there's not even a good vocabulary out there for all of us, right? And so it becomes really difficult for us to get traction within an organization or connect with our peers across the industry when there's not a vocabulary built up around the practice, right? And so I have encountered plenty of folks who are doing something like this, right? But at this stage where it's probably something that should exist right now, but it surely does not really, right? So there's not like a common vocabulary for explaining what we're doing either within our organization or to our peers out in the industry. So I think there's probably a lot more of it happening than people realize. I think we just need to like introduce consciousness raising events where you like get together and tell each other our troubles and use continuous verification language to talk about it.
Continuous verification conf. How would you even start? It just seems like an obvious thing. Yes, I want this. I do not like it when things break and we cannot fix them. I got to get me some of that there continuous verification. Now what? You know, you're smart, write your own. I'm like, how do you even start?
Yes. I think it's extremely difficult for multiple reasons. Like number one, if it was easy to identify the safety boundary, then all of us would be doing it already, right? So we, are very immature when it comes to that. And we also tend to think of the safety boundary as something that exists and it just stays put and it doesn't really move a great deal. But I can tell you firsthand that is not at all true. I think overall, and like DevOps is certainly getting us there, but we need a lot more. I am troubled in our industry by the emphasis on productive labor, right? So we want to get things out in production. Yeah, cool. And there's like no emphasis, almost zero, on reproductive labor, which are things that like keep systems healthy and keep them kind of growing and happy and healthy like you would for a child, right? And I think that's where all of this falls. Identifying the safety boundary and becoming sensitized to it is just something that we don't value in our organizations, because what we value is just pushing out more code all the time. So I'm encouraged by the trend that we see towards valuing that different kind of labor, but I don't know. Yeah, it's total, I don't know. It's very rough out there.
Yeah, software gardening, looking after your...
Yes.
Well, just some of the things you said made me think, here we are in Australia bailing out our garages. And when you were talking about the incident that started out, happening this far apart, and then it was coming closer and closer and closer. And I'm like, oh, weather events. Yeah.
Yeah. Yeah. And that is certainly something that all of us can do right now. We can go talk to whomever it is, right? Like, who is that person that you're like, oh my gosh, something seems weird. I better ping fill in the blank, go talk to that person and like try to sensitize them to the weird stuff. And they probably have a lot of good information about where the safety boundary is, right? They probably have some leading indicators. Well, when this happens, I jump in and do this.
Yep.
And so if you can just get that out of their heads and put it into code, ta-da!
And the rest of us can sit around and go, I knew there was something funny going on. I knew it.
Yes.
All right, friends. Any further questions? And then we will let Kat call it a night. But that was super interesting. I'm feeling sort of enlightened, but also like, wow, there's a lot to learn about this stuff, hey?
Yes.
But as you say, if it was easy, anyone could do it.
Yeah. But think of the edge that you'll have over everyone else in the industry if you even invest a tiny amount of time in this, right?
Yeah, it seems worth it. So awesome. Thank you very much. Thank you on behalf of YOW for your time, and thank the joinees for joining us, and everybody else. Catch us on the recording, and we'll see you at the next YOW Online. Cheers.